Well, hello there folks, I hope you're doing well. In this video we're going to be talking about section or chapter 8.4, calculating length, cosine ratio. You're going to find this on page 226 of your workbook. So let's start with the try these. What is the measure of angle B? Well, angle B is this one right here. We can figure that out by remembering that in a triangle, the angles add up to 180 degrees. So I take 180 degrees and I subtract my 90 degree square angle or right angle and my 40 degree angle A. And when I do that, I find that angle B is equal to 50 degrees. It then says calculate side B or lowercase b to one decimal place. The way I need to do that is by using the learning from the last section. B, according to the last section, because it is the opposite side, it's going to be equal to the sine of this angle. I'll even write it there. So the sine of 50 degrees multiplied by the hypotenuse, 3.0 meters. And when I put that in my calculator, remembering to use everything, or using my brackets if I need to, I get an answer of 2.3 meters. So B is equal to 2.3 meters. And that's it for the try these. Let's move on. Using the skateboard ramp from the city of Airdrie from the last section, we are now going to learn what is called the cosine ratio, or do some examples. So what sides are adjacent to angle A? Remember, adjacent means next to, and so in the case of triangles, adjacent is the side next to the angle that is not the hypotenuse. So an example of this would be AD, right there. Another example would be AF. Now, using the chart from lesson 8.3, what is the ratio for the side that is adjacent to 40 degrees over the hypotenuse? So an example side is AD, and that was 5 millimeters. And AE, or pardon me, not 5, 15 millimeters, and AE, which was 20 millimeters. And 15 over 20 is the same as 0.75. 3/4. AF now is equal to 30, and AG is equal to 40, so it's 30 divided by 40, or once again 0.5. So what do you notice? Once again, they are the same. Something you'll be seeing a lot of. They are the same, they are the same, they are the same. So what is the cosine of 40 degrees? So I get my calculator out, and I type in cosine of 40 degrees, and I find that that is equal to 0.766. What do you notice? Well, 0.766 is close to 0.75, because just like the sine ratio is, or the sine of an angle is related to the ratio of the opposite side divided by the hypotenuse, the cosine ratio is related to the length of the adjacent side divided by the hypotenuse, or it is that decimal that you find. Number 4 says draw two triangles with a 25-degree angle, measure the sides, etc., etc. So you can definitely do that. I won't be doing that here, but if you do that and compare the adjacent sides over their hypotenuses, you'll find that the ratio, or the ratios, are the same. What conclusion can you make based on your results? You can make lots of different conclusions, but I could say the sorry, that looks like ratio. That's ratio. The ratio of the adjacent side divided by the hypotenuse of triangles, or sorry, I'll say right, of right triangles with matching angles. So the ratio of the adjacent side divided by the hypotenuse of right triangles with matching angles, or let's say identical angles, with identical angles is always the same. Which is the cosine of the angle. So the ratio is always going to be the same, and it's going to be equal to the cosine of that angle. So in this case, with my 25-degree triangles, it doesn't matter how big the triangle is, the ratio, so the adjacent length divided by the hypotenuse, is always going to equal a decimal that is the same. And that decimal is going to be the same as the cosine of 25 degrees. And this works for any sort of degrees, or any sort of right triangle with a given angle. So let's do an example here. During the winter, Kim and Bo snowmobile to each other's place. How far is it from each friend's place to the nearest town, to the nearest 1/10 of a kilometer? First of all, what is given? We are given angle, it's called angle K because it's across from here, from the K. So it's opposite the K. So this would be angle K, which is 24 degrees. The hypotenuse of the triangle is our big one, 5.5 kilometers. How far is Bo's place from Kim's place? Well, Bo's place, or sorry, how far is town from Bo's place? And then from Kim's place. So Bo's place to town is little b. Little b is what we're looking for, and it is adjacent to the angle of 24. So we can use our cosine ratio. The cosine of 24 degrees is equal to our adjacent side, which we don't know. So it's our unknown divided by our hypotenuse of 5.5. So that's the same as 5.5 times the cos of 24, which if you put that in your calculator, and it wants it to the nearest 1/10 of a kilometer, so that is equal to 5.0 kilometers. So Bo's place is about 5.0 kilometers from town. So I can even put that. 5.0 kilometers from town. And then what about Kim's place? Well, Kim's place, the adjacent angle right now is unknown, but the adjacent side is K. So to find out Kim's place, we could do two things. We could use the sine ratio because Kim's place, the K here is opposite from 24, so we could say 5.5 times sine 24. But since this is the cosine section, we want to do the cosine, which means we just have to find angle B, or this angle right there. Well, that is going to be equal to, once again, 180 degrees minus 90 degrees minus 24 degrees. Because there's 100, it's going to add up to 180 degrees, so I just find out what these, or subtract these two from 180. I'm left with this angle, which is 66 degrees. So I need to use the cosine of 66 degrees, and that'll give us our unknown adjacent angle K, and we're going to divide by the hypotenuse of 5.5 once again. So it's going to be very similar, very similar. It's just instead of 24 this time, we're going to use 66 degrees. And when you put that in, you find it to be 2.2. So Kim's place is about 2.2 kilometers from town. So now you have two ways to solve a triangle, or to find an unknown side of a triangle. As long as you know the hypotenuse, you can use either the sine ratio to find an opposite side, or a cosine ratio to find an adjacent side. And the next thing we're going to be talking about is the third ratio, for those weird cases where we don't have the hypotenuse but want to find it. But that's everything for now. If you have any questions, please do let me know. I hope you have a fantastic day, and I will talk to you later.